Is your lazy spa pump leaking water from the bottom? If I show you this bit of video in the top right hand corner, you can see that I've got a drip 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 coming from the bottom of my pump unit. Now one of the common leak points on these is the mushroom that forms the one-way valve for the air jet system. And one way to tell whether that's the cause of the leak is to watch the leak, switch the air jets on, and if the leak either slows considerably or stops, then that's probably the cause. I tried that trick and it didn't work in this case, so I know that's almost certainly not the cause. Something I have noticed though is that when I turn the circulation pump on, the leak speeds up. That leads me to suspect that the leak is on the output side of the circulation pump somewhere. But of course I can't see it. Further investigation is required, which basically means taking the pump apart. So let me show you how to do that. A cautionary note though, you might think that it's, just drip, drip, drip. In my case, one drip every second, and you might well think from that, oh, that's nothing, I won't worry about that. But I was away last week for 6 days and that drip emptied half of my tub. That's 600 litres. It's not just the cost of the water, of course, which, isn't going to break the bank, but it's also the cost of the energy that went into heating that water, which is considerable at the moment, as we all know. Not to mention, of course, the inconvenience of having to refill it and reheat it before being able to use it again. With all that entails in terms of getting the chemicals right, blah, 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 blah. Before doing any work on your pump unit, don't forget to unplug it first. That way it's absolutely safe, electrically speaking. Don't forget when disconnecting your pump unit from the tub to put the bungs on the water holes and on the air jet input. Now to get a better view inside, I need to take the bottom cover off. And to remove it, you will need to undo the 6 screws I'm showing here. Bear in mind that for this screw, you will need a long screwdriver with a minimum shaft length of 125 millimeters. And the screws are Phillips number 2. And to get it off, lift the front to separate it and remove it from the grommets. Then lift that side and it's hooked in here, so remove it that way. You can undo the earth lead with a 7mm spanner or socket, and then you can put the cover to one side. Now the dog could see the rabbit. If it was the air jet one-way valve leaking, allowing water through, that valve is in here. Basically that big mushroom I showed you. If that deteriorates, water comes past that down into this chamber here and leaks out of this one-way valve here, which is normally open to allow any excess water to drip out. But if the air pump is on, then the air that's pumping through there closes that valve. That's why the water leak stops when the air jet's on. To give myself a fighting chance of being able to see what's going on and see the leak, I'm going to remove the bottom half of the casing. So undo the 6 screws that hold it to the upper half. Make sure to hold the 2 halves together. Once you've got it on its side, the bottom half can actually be pulled away, and then continue to turn the bottom half so that it's the right way up. And prop the top half up in such a way that you can get at the control panel, and also you're not straining these wires. With the top half of the casing off, we can now see the major components more clearly. This unit here is the heater. At the output of the heater unit here, we've got the flow sensor and the temperature sensor. We've got a transformer here for the control panel, and this unit here is the centrifugal air jet fan and motor, which has got a filter in here which can be unclipped, so the filter can actually be cleaned and or replaced. But anyway, that's by the by. It is a common failure on these for the flow sensor to fail and need replacing. This device on the side of the heater outlet looks like it's an overheat detector. It's just behind the reset button. I've attached and filled my easy scale. I've done a video on how to use this and do a descale. I'll link to that in the description. I've filled it so that I can run the pump and look for where the leak comes from. Here goes. Pump running. If I get in there with my phone to video it, sure enough, it's the lid of the flow sensor that's leaking. And as the water drips out, the water level in the easy scale is going down as well. And what do you know? The back end of the heater unit is also leaking. If I'd known this beforehand, of course, I would have got a set of seals ready to use. This will only fit one way on, so you don't have to remember which way round it goes. To remove the heater, undo the 2 earth connections on the side and the 4 screws that hold the 2 heater cradles into place, and lift the cradles out. I only need to access the rear end of it. Removing the 6 screws at the back end of the heater allows you to remove the cap which seals the water flow channels. I found it quite difficult because of the amount of scale and chlorine salt, but it will come off if you just gently ease it. With the poor state that this end cap and seal is in, I've decided that in order to do a proper job on this, I'm going to have to take the heater out. So I'll show you how to do that now. With the unit on its side, either with a flat screwdriver or a 6mm socket, undo the hose clip that holds the intake pipe to the pump. Undo the pump unit connection from the transformer. You can then pull the intake pipe off the pump and put the unit back the right way up. Cut the cable tie here. Disconnect the spade connectors at the overheat detector. Disconnect the connectors to the flow sensor and the temperature sensor by squeezing the little legs to the side and pulling apart. If you've still got the lift handle in place, remove it and undo the 2 screws, one at each end, that hold this black cover over the ECU, and lift it away. With a felt tip, I'm marking these white cables 1, 2, 3, 4. I don't know that it matters which way round they go, otherwise they'd be marked anyway. Then with your number 2 Phillips, just loosen the screws, 2 or 3 turns each, and lift the spade connections out. Release the white cables from position, being careful not to snag any cables. Simply lift the heater and the pump unit out of position. With the heater unit on the bench, I can now remove the end cap and the gasket, and you can really see the corrosion scale and chlorine salts on the end of the heater now, also stuck to the gasket, which is in quite poor condition, so no wonder it was leaking. Using a nylon brush and my pick, I'm very gently cleaning the crustiness off this gasket. You can use the end of the brush to crush some of the crustiness and it will come off as powder then. And judging by the state of this one, I would say that the trouble with buying a second-hand heater unit is that you can't know that a second-hand one is in any better condition. Removing the pump outlet from the heater is exactly the same as removing the other end. 6 screws and then tease it off and recover the gasket. There's plenty of corrosion product around all the nooks and crannies in the end caps, so I'm cleaning it up with a brass brush and my pick, and clean the other gasket up in exactly the same way as the previous one. Coming onto the heater unit, do exactly the same thing with that. Clean up the ends with your brass and nylon brushes and either a flat screwdriver or your pick. Now, looking at the end of this heater unit, I'm thinking that all this white powder that I'm taking off here should be aluminium corrosion, because I can actually see areas where the aluminium has corroded away and there are cavities and bits, and there's also white deposits all the way through the channels. Well, what that suggests is that as much as you can refurbish them in this manner, it suggests that they will have a finite lifetime, and that eventually the corrosion will become so bad that there's nothing more you can do with them, in which case you've got no choice then but to buy a new one. To remake the seal at each end, first of all I'm filling the groove with some automotive silicone gasket maker. I've filled a 2cc syringe, which sort of thing you can pick up from any chemist, for more precise application into the channel around each waterway. Actually, this is a better application method than I had a moment ago. Point the syringe straight down into the groove and just squeeze a little in, and put the gasket back in, making sure to get the little rubber wall into the groove. You can feel it when it goes in. I think it's important here to use a good quality RTV sealant. I was going to say that the non-corrosive property of the RTV was important, but this is an automotive grade which is used for gasket making on engines, so it should be suitable for this application. Then put a thin bead around each cavity again. Try not to put too much of an excess on. The instructions do say to allow it to skin before putting the parts together. Put the end back on the heater, push it as far as it'll go. You can look inside there actually, and I can see that it's not squeezing too much excess out, and put the screws in and go around and make sure that they are all done tight. Now I'm going to do the same with the flow sensor. Place the gasket in and screw it on the outlet housing. And you beauty. Silicone sealer squeezing out all the way around, so it's obviously full. But just make sure that you can hear the float moving freely, that you haven't accidentally got it stuck in position. In fact, if you look down that tube, you can see the float. Now I'm going to leave that for a couple of hours to set before I put it all back together and run any water through it. Also, before putting it back together, either with a 6mm socket or spanner or a flat screwdriver, just check the security of the hose clamps. Also, whilst I've got this assembly out of the pump unit, inside here is the impeller for the circulation pump. It's a common problem for those to corrode and get damaged, and that can be a cause of the E02 problem. So I'm going to check mine while we're here by undoing these 6 screws. Don't lose the little nuts that are on the other side, depending on which way up you've got this. And be very careful once you've undone the last screw. It comes loose. Gently separate the 2 parts. Lift the little rubber cap off the centre shaft, and then the impeller and the magnet lifts out. It should rotate freely on the shaft. Put it back the opposite way to the way you got it off. Again, the gasket on this isn't so impressive, but since there's plenty of land around it, I've just put a smear of gasket maker around that land on the outside of the gasket, and then put it back together. A simple test to see if the seals that you've refurbished are watertight. Temporarily reconnect the input pipe and fill the heater and pump with water. It takes about 600 ml or so. Do so until you can see it coming up this input pipe here, and look out for any drips or leaks coming from any of the joints. And for me, so far so good. When I started taking this unit apart to investigate the leaks, I actually didn't know that you could buy new seals for these heater units. I'll put a picture in the corner of the screen for you. But even using new seals, I would still use the silicone gasket maker, because the corrosion on each end of the aluminium heater matrix pits the aluminium, making small holes in it. So you want to be able to fill those little pits and holes. So a little bit of sealer that's flexible and will flow into those, I think is still necessary. I'll put some links in the description for you to sets of seals. All that remains now is to put it back together the opposite way to the way you took it apart. But I have got some care points for you. Care point 1. This involves the attachment points for the earth connections on the heater. Now this is where the main earth lead from the mains comes in as well. So be careful to make sure that you get those earth connection points on the same side of the heater as the flow sensor. Now I'm blowed if I'm going to be taking my heater apart to get this right, so I'm going to have to drill and thread new holes here for that. So don't make that mistake like I did. Care point 2. These connectors here only connect together one way, so don't try and force them in if they're going the wrong way. Care point 3, don't forget to reconnect the thermal cutout. Nothing will work at all if you don't connect that. Care point 4, don't forget to slot the pipe grommets over the casing as you're fitting the heater and this pipe down here. It's the devil's own job to push it in afterwards if you forgot. Care point 5, whilst you're reconnecting the heater to the board, check all the other connections to the board as well. I actually found that my live connection from the main input was slightly loose. Care point 6, don't forget the ECU splash shield. Now most of these connectors are not waterproof, and this one that leads up to the control panel on the top, I found a little bit of corrosion on this. If you wish to, you can put some silicone grease or dielectric grease, same thing, in there before you put them together to help to protect the pins from corrosion. That, sure enough, no more drips. And the heater is pulling 1900 watts as normal. Job jobbed.